Assalamualaikum. Hi. It's hot, isn't it, lately? The weather is fairly dry and hot at the same time. This is one of the effects of global warming. We've been knew this even during school days that petroleum has been one of the many factors that causes global warming. So, the dielectric strength of mineral oil and natural ester dielectric liquid blends is basically an addition of certain ratio of natural ester into mineral oil to reduce the usage of petroleum in oil insulation for transformers. Moving on, the big why of this study is because of the wide use of mineral oil that does not give any positive impact to the nature. The study uses this motion as a motivation to create an eco-friendly but sustainable alternative. The vast use of mineral oil is because it offers stable energy resource at a very low cost, but it is still bad for environment. So, this study will investigate the sustainability, reliability and industry worthy of the solution. There are three objectives. First, to develop low-viscosity ester. The ester was extracted from waste cooking oil. Yes, the cooking oil that you discarded after you cannot use it anymore. Next, to mix low-viscosity ester with mineral oil at certain ratio. There will be 9 samples representing 9 different volume ratio of natural ester and mineral oil. Lastly, to measure the properties of mixed oils, such as breakdown voltage and moisture content. The first test is called the breakdown voltage test, and the other test is called Fisher method. The scope of study, it focuses on identifying the properties of the mixed solution at certain ratio and its capability to be used in the industry. As you can see, this is the comparison between mineral oil and natural ester in terms of properties. For the electrical property, the breakdown voltage for both oil is the same, which is at least 35 kV. However, the chemical property, the water content for mineral oil is much lower than natural ester, which is at 35 parts per million, whereas natural ester is at 200 parts per million. There are a few disadvantages for mineral oil, such as it is a non-renewable energy, so it will run out one day. And it is also a trigger for acid rain, so it really messed up with the sea ecosystem. Well, good news. For natural ester, the disadvantages is not nature related. Well, firstly, it has higher pour point. Well, pour point is when the oil starts to flow under the standard test condition at certain temperature. Usually it is applicable to country with negative temperature such as Greenland or North Pole. I don't know if North Pole ada transformer or not. I don't know. And next, it is high cost. Yeah, it is quite expensive to prepare it to compare with mineral oil. Heads up, due to PKP, you have to change to PFAE, which is palm fatty acid ester. This is due to time restriction allowed for students to visit the lab to run tests or even prepare the ester itself. Well, the ester was done and dusted, but PKP happened, so kudos to our government. And next, the footages or pictures used in this slides, the next few slides is from my phone. So the content audioly, visually is less professional. So I'm sorry for that, but I'm trying to make ends. So I'm using as much as resources I have to make this presentation proper. Lastly, there are 9 samples, and each samples are labeled according to the volume of concentration of PFAE, which is 10% to 90%. First of all, the filtered waste cooking oil was heated for 10 minutes at 120 degrees Celsius to decrease its water content. And then, prior to transesterification process, the waste cooking oil will cool to 60 degrees Celsius.
For the preparation of the blends, firstly 7 grams of sodium hydroxide was added into 250 milliliter of methanol to form a catalyst. Then the catalyst was added into the waste cooking oil and stirred for around 5 minutes. After 5 minutes, the mixture was covered in aluminium and placed in a thermos for about 48 hours. After 2 days, the mixture was cleaned with hot water and the process was repeated for 6 times. This part, it's quite interesting because I asked my supervisor once, IR Imran, about this repetition of cleaning process, why it has to be 6 times, why it's not 5 or 4. And then he told me about how Muslim perform sama. He tried it when he stuck during this process. And he told me that he washed the oil 6 times because of the 6 parts of water to wash using performing in the sama. The solution was heated for around 10 minutes at 120 degree to decrease the water content before being cooled to room temperature.
As you can see from the video I attached, is the oil washing process that I perform. And transesterification is pronounced transesterification. It is a reversible reaction in which one ester is converted into another. I copied it from Merriam-Webster. Okay, moving on. So for the breakdown voltage test methodology, firstly, the sample and the test cup were calibrated with the room temperature, and then the container was swirled with the sample. After 1 minute, the test shell was rinsed with small amount of the sample, and the remaining was added afterwards. The voltage rising was set at a rate of around 0.5 kV per second until the breakdown occurs. Step 4 was repeated for 5 times, and the mean value from the 5 tests was tabulated.
Moving on to Carl-Fisher test, we'll be dealing with syringes and needles, so the tools were rinsed every time the sample was changed. The sample mass was recorded before and after injection, and step 2 until step 4 will be repeated 3 times and the average value was tabulated.
So, from the graph, we can see that at 10% PFAE and 90% mineral oil, it gives out the lowest PDV reading, which is at 23 kV, whereas the highest reading is when the volume of concentration of PFAE is at 70%. However, the ideal reading for breakdown voltage is when PFAE and mineral oil are at 40% and 60% respectively, which gives out 30 kV breakdown voltage reading. For moisture content, the lowest reading is when the PFAE is at 10%, which gives out 3.9 parts per million. And the highest is when the PFAE is at 90%, and it gives out a really outstanding reading, which is 42.43 parts per million. That's a lot. And the ideal out of all samples is when the PFAE is at 70% and the mineral oil is at 30%, which gives out a really nice reading of 28.2 parts per million. To conclude, I am confident that this mixture is capable to perform well in the industry due to its sustainability by having a convincing lifespan. Apart from that, it will also be very reliable because of its impressive readings for both tests, and that leads to an industry-worthy oil insulation for transformers. To end this, I would recommend to choose when the PFAE is at 80% and the mineral oil is at 20%, the solution, because as you can see from here, the reading for 80% PFAE is 26.2 parts per million. It is advisable to have lesser moisture content to avoid aging in the transformer. And also, the breakdown voltage for 80% PFAE is in the loop 34 kilo. Yes, 34 kilovolt, because the range is from 30 to 35 kilovolt from the articles that I've went through. So I'm really honored to present this. I really love this topic, and I hope that I've done a really good job, and I hope you can take something from this presentation. And if there's any question, then text me. Inshallah, I'll reply. And I hope I'll see you on Monday for the Q&A session. Inshallah. Assalamualaikum.